The repository has all of the words that pertain to what I'm about to talk about, so it should be pretty easy to find if you're curious on what I'm about to present. Cool. I will start by talking about myself a little bit. My name is Bex. My pronouns are they, them, and theirs. And I'm a software engineer on the data team at ShopRunner. We are an e-commerce startup that connects retailers with customers. The retailers offer free 2-day shipping, and we offer them some cool applications and features for their websites and some awesome analyses. It is a great place to work. I love all of my coworkers. Some of them are here. We specifically use Kotlin for a lot of data processing and web services to use APIs to serve up that data to various other features and applications across our teams. Before I get started, for anyone who doesn't know what DynamoDB is, it is an AWS NoSQL DB. That's a lot of letters and not a lot of meaning for some people. So it is a non-relational schemaless cloud database. It is a database where not all of the rows have to have the same schema. They don't have to all have the same columns or attributes, and you aren't necessarily joining one thing to another thing. The only requirement on your objects are that the key attribute for the table is provided. Those keys organize the data so that you can search through them pretty quickly. They have a whole developer guide to cover more than I will cover in this small 30-minute time span. For the purposes of this presentation, I have put together a short Spring app based on the Kotlin Lang examples. So that's just a few files to start up a quick web server. And I will be running a DynamoDB with Docker, which is also fairly convenient for integration testing on your local environment. Cool. What DynamoDB data looks like is kind of like JSON, but there's types on it despite the fact that it's schemaless. I have done some example DML, or data manipulation language, to show you what an object in Dynamo might look like. This, hopefully fairly readable, is an example object. It is a user for our database. It will have a first name, a last name, a title, which is a fairly complicated, not that complicated, but a little bit, map with a bunch of different attributes of different types, and then a couple more strings at the end for height, and a favorite JSON blob, because we all love JSON and strings. It's the best thing. That's sarcasm. Cool. One of the benefits of reading this weird JSON blob into Spring and Kotlin is, in addition to the reduction of code that Spring gives us by their annotations, we get to lose even more by bringing in Kotlin. We can read the maps from our DynamoDB object directly into data classes, no real in-between. We can even use annotations to convert the types if need be. And all of the null safety question marks that Kotlin brings in means that we can drop a bunch of the if null then this that we might otherwise need. The only danger is if Dynamo passes a null into Kotlin, you've got to find out how to deal with that. Cool. To start with, first things first, we will talk about describing a table to contain our lovely data. The properties on the Spring class will describe what the table has. For our purposes, we really only need the keys. We can bring in as many or as few attributes as we would like. In addition, from a library that I will talk about on the next slide, we can automatically generate the table so that we don't even have to write table creation statements or anything else. If the table already exists, for example, on your Amazon account, just write your table based on what you're going to be reading. So, our example table is this long, which is not very long at all. All we have is the first name, which is our hash key or kind of a primary key for Dynamo, and the last name, just a regular old attribute. One interesting thing you might notice is there is a constructor here. The Amazon SDK requires that your table has a no arguments constructor. Kotlin will provide this if all of your arguments on your data class have defaults. But if they don't, you will need that no argument constructor. Kotlin does have a no arg constructor plugin, but it uses the entity class from Spring, which we're not using because we're in Dynamo, and that's a different subject. So all of your arguments should have defaults, or you should have this weird constructory thing. Just know you need to have that no arg constructor. Cool. As mentioned, there is another library that I will be bringing in to help us out with this, and it is a JPA Provider. This is a Java Persistence API, if you haven't heard that term before. It's usually used with tables that are relational, like MySQL and Postgres. There is another one for Dynamo specifically. It is called the Spring-Dynamo DynamoDB library. I have a link to it on GitHub up here. It implements all of the create, read, update, delete methods, all of those basics that you might need. So if you're finding by ID, deleting by ID, it just makes those functions for you because that's the basics. You shouldn't have to write those. We're keeping it simple. For some of the other ones, so first one for attributes specific to our tables, it will use dynamic query generation to make those for us. So if I want to search by first name, all that will look like is creating a function find by first name. I don't even have to write the function. It's still just this small. Cool. That is all brought in by this provider. To hop back over here, this enable scan is what tells Spring that this is a repository that's going to bring in our data from the table. So once you add this, the rest is all taken care of. Then we have all of these functions that we can use in our controller to just find, update, delete, delete more in case that wasn't enough. Everything you might need. Cool. So, controller, data, repository, table, that's basically all we need. I ran this application ahead of time so I could move on. What our data will wind up looking like, if I can find my Chrome window, is this. We have brought in our key, we have brought in our attribute. That's the whole thing, start to finish. But we can do a little better. When we have this one with just the first name as the key, that's the only thing that needs to be unique. So we can only have one user per first name. So everyone who's named John, Michael, Emily, or Katie has to move a little fast. So what we can do is instead make a more detailed key called a composite key. DynamoDB allows two different keys, a hash or partition key, a range or a sort key. Hash and range are the words we're going to use from here on. The class containing the hash and range key is the primary key. So what happens is instead of just having a hash key and just having a range key, for our table, we will combine them into one ID class. This is because the repository requires one ID. You can't go to, say, a MySQL table and say, I have two IDs, actually. Most tables not very okay with that. So in this case, we squish them into one class and say, look, it's one thing. This is fine, trust me. And it works. So for this case, I will be doing a little bit of live coding on our table. A big part of live coding is being able to copy and paste and find the code that you need that does exactly what you want ahead of time. Okay. So here we go, live coding. Trust me, no questions. This is what it will look like. In this case, we have an ID field now, and it is a user ID defined separately. This has our hash key, it has our range key, it does not have getters and setters. Those aren't needed here because this is one of Kotlin's data class. Interestingly, back over on our table, we do have getters and setters. And we have the same hash key and range key annotations again. Not very Kotlintic, however you say it. It's not the best for Kotlin, but it is required. Trust me, I've tried to remove them like twice. It hasn't worked. I'm so sorry. I tried. But for this case specifically, you gotta have them. For all of your other attributes, you don't need them. For these two, because what it has to get and set is in a whole nother class entirely, you do need these getters and setters so that the Amazon code and the JPA knows where to look to find your actual IDs. Cool. So, another part for our data. We had that large map that contains another map from our DML. we want to load that in. For now, we're just kind of dealing with the simple strings. So what can we do to load a map within a map? Well, clearly we could just change the type. We could just have a map of a string to a string, or we could have a map, this is not the right one, a map that leads to another map. The problem is that back in our DML, it's not just a map to a map. One attribute is a map to a map, but these other parts of it are just strings. So this won't all fit the correct type. What we can do instead is bring in a data class. Yet another one. They're my favorite part of Kotlin, in case you can't tell. For this case, we will just bring in a title for our user. So we will have another attribute. For our title, and it will go directly into a data class, which I have already made. The data class, we're back to not needing getters or setters. We just need to specify the types of our attributes. And then because we've said what each attribute's type is separately, we don't need to worry about how they aren't necessarily the same. It will take the attribute for the variable name from our DML and fit it into this data class automatically just by having this piece here. All right, so if I rerun the application, we should be able to see what this looks like. I ran this earlier, but it did not go. So we will go from our simple first name, last name to having everything. This whole JSON blob is loaded from one data class. All of these are into each specific attribute. We've got the intro, we've got the prefix, we've got the suffix. If we wanted to, we could nest even further. We could make a data class for this second map within this map and just keep going, like the movie Inception. We can have as much as we want. So, thinking again, going back to another part that we want to load in. I mentioned earlier, we have the favorite JSON blob. We don't want this to be a string. Nobody likes that. We also have a height, also a string, but it's actually numbers. Not that fun. What we can add in is type conversion. Built in, we have a type converter for JSON blobs. We don't even have to write this. This is just type converted JSON. But if we needed, say for height, a custom converter to tell it how to take the two pieces of a height, feet and inches, and bring them into feet and inches for data class, we can do that. It is a type converter. You just specify how to convert it into a string from the data class or convert it from the string into the data class. We again don't need getters and setters on the data class. Bonus points, because try and catches are expressions, we don't need to worry about instantiating the initial object or returning the right thing. We can just have our paths and create the objects that we need, or if we can't create it, return a null. And that is, there was one more cool thing. Oh, we can drop the if null then this that we would usually have to check if the string we provided is null. Like, it'll just handle that. To give a quick example, this is all based off of the Amazon code that they use. When they write it, their class has to have all of these getters and setters. Their converter has to have this whole if statement. It has to have all of this set up ahead of time. It has to have this end return statement. We're taking none of that. We're just getting rid of all of it. Put it away. The real 2-day shipping is we get to ship our code in 2 days because we don't have to write all this nonsense. Easier. So we have our JSON converter. We can sneak in our super cool custom converter. We will specify the data classes that these will fit into. And And once we rerun it, we will see all of those strings turned into something much nicer and much easier to work with. Because instead of having those random strings, we've got something that actually makes sense. I've dealt with a lot of strings in my time. These are much better. All right. That's all I got. I love data classes. I love expressions. I love question marks. Between all of these, we've reduced our code so much that we've probably got more @ annotations than we do actual code. The code looks a little bit like your social media feed, but trust me, it's all right. We'll be fine. It all loads perfectly. That's my presentation. Thank you very much for listening.